We are now going to show how we can identify each type of quadrilateral based on both their sides and their angles. First, we are going to show that there are four ways to identify a quadrilateral as a parallelogram. The first one is if both pairs of opposite angles are equal. So both pairs, this is one pair of opposite angles, but we also need another pair of opposite angles. So if we have two pairs of opposite angles equal to each other, it's enough information to say it's a parallelogram. Next, we have the scenario where both pairs of opposite sides are equal. So if this side and this side is equal, as well as this side and this side, in other words, if both pairs of opposite sides are equal, it's enough information to identify the quadrilateral as a parallelogram. Thirdly, if both pairs of opposite sides are parallel, so this side is parallel to this side, and this side is parallel to that side. In other words, if both pairs are parallel to each other, that's enough information to classify it as a parallelogram. The fourth and last way that we can classify a quadrilateral as a parallelogram is when we say that one pair of sides are both equal and parallel to each other. So you just need one side that are equal and parallel. So instead of this side, if the other sides were equal and parallel, that would also be on its own enough information to classify the quadrilateral as a parallelogram. There are four ways in which we can classify a quadrilateral as a rhombus. The first way is if all four the sides are equal. So if each of the four sides have the same length, it is enough information to classify it as a rhombus. Next, we can classify a rhombus or quadrilateral as a rhombus if both pairs of opposite angles are equal. So we have one pair of opposite angles, but we need both pairs of opposite angles. So we have two pairs of opposite angles are equal, and then a pair of adjacent sides needs to be equal. So this side here and this side here are both, if they are both equal and both the opposite angles are equal, it's enough information to classify it as a rhombus. So obviously if both the opposite angles were equal, and for example rather this side and this adjacent side was equal, then it would also be a rhombus. Yeah, so we just need one of the adjacent pairs of sides equal. The third possibility to classify a quadrilateral as a rhombus is if both pairs of opposite sides are parallel. So this and this side are parallel, and if these sides are parallel, so the two pairs of sides are each parallel, and a pair of adjacent sides needs to be equal. So for example, if this side and this side is equal, and we have two pairs of sides that are parallel, that's enough information. So adjacent sides are sides that meet each other to form an angle or a vertex. Finally, the last possibility to classify a quadrilateral as a rhombus is if one of the pairs of sides are equal and parallel, and once again if a pair of adjacent sides are equal. For example, this side and this side meet to form this vertex. So if for example they are equal, plus we have one pair of sides that are equal and parallel, it's enough information to classify this as a rhombus. Obviously we could have selected another pair of adjacent sides, for example this side here and rather this side here. There are four ways to classify any quadrilateral as a right rectangle. The first one is if there are four right angles, or to put it a different way, four angles of 90 degrees. So we have 1, 2, 3, 4 angles of 90 degrees. That's enough information to identify a rectangle. The second way that we can identify or classify quadrilateral as a rectangle is if both pairs of opposite sides are parallel. Okay, so both pairs of opposite sides are parallel. So we have this one pair parallel, and then we also have the second pair parallel. So both pairs of opposite sides are parallel, and there's at least one right angle. So we have at least one of the four angles at 90 degrees. The third way that we can classify a quadrilateral uniquely as a rectangle is if both pairs of opposite sides are equal. So both pairs of opposite sides are equal. So we have one pair, two pairs of opposite sides are equal, and once again if it has a right angle. So here we have a right angle, it can be any of the four angles. The last way that we can classify any quadrilateral uniquely as a rectangle is if we have one pair of opposite sides that are equal. So one pair of opposite sides is equal, as well as parallel. So it's not only equal, that pair is also parallel. And there is, you guess it, a right angle. Boy, it is one of the angles. There are two ways that we can identify, or rather classify, any quadrilateral uniquely as a square. The first one is if all four of the sides are equal, plus we have at least one angle that is 90 degrees. Then it's definitely a square. The second way to uniquely classify a quadrilateral as a square is if we have four right angles, in other words angles of 90 degrees each, and a pair of adjacent sides that are equal. So for example, if this side and this side is equal and they are adjacent because they meet together to form this 90-degree angle, that is enough information to classify it as a square. Obviously we could have used other adjacent sides. For example, we could have said if this side and this side that are adjacent to each other are equal and we have four angles that are 90 degrees, it's enough information to classify the quadrilateral as a square. Quadrilateral can uniquely be identified as a kite if two pairs of adjacent sides are equal. So both pairs of adjacent sides should be equal. So this side here and this side here are adjacent because they form together an angle and they are equal. Also, this side here and this side here are adjacent because they form this angle here. This angle here. So we have two pairs of adjacent sides that are each equal, and that is enough information to classify this quadrilateral as a kite rather. We can classify any quadrilateral uniquely as a trapezium if any one of the following two scenarios apply. First one is if one pair of opposite sides are parallel. So if this pair of sides are parallel, then we can neatly classify this quadrilateral as a trapezium. The second way that we can uniquely classify it as a trapezium is if one pair of co-interior angles are supplementary. which means one pair of co-interior angles add up to 180 degrees. For example, if this angle and this angle together add up to 180 degrees, let's say the one is maybe 130 and the other 50, or let's say the one is 140 and the other 40. As long as they add up to 180 degrees, then it's enough information to classify this quadrilateral as a trapezium.